You're standing on a beach. The sun's blazing, your throat feels dry, and all around you, nothing but endless, sparkling blue water. You lift a handful to your lips, desperate for a sip, but you know it would only make things worse. It's strange, isn't it? We live on a planet that's covered in water, yet we can't drink almost any of it. So, here's the question. What would it actually take to make ocean water safe to drink? And could we ever do it on a global scale? To understand why, we need to start with something simple: salt and cells. Every liter of ocean water holds about 35 grams of salt, roughly 7 teaspoons. That might not sound like much until you realize your body is built to handle only a tiny fraction of that concentration. Here's what happens if you drink seawater. Your body gets overloaded with salt. The salt pulls water out of your cells to balance things out. And that means your cells start to shrink. You actually get dehydrated faster than if you drank nothing at all. It's like watering a plant with vinegar. The more you pour, the faster it wilts. So, in short, it's not that ocean water is poisonous, it's that it hijacks your body's own water supply and turns it against you. But here's the twist. Humans can make ocean water drinkable. In fact, we've been doing it for decades. It's called desalination, the process of removing salt from seawater. Today, countries like Saudi Arabia, Israel, and Singapore rely on desalination for a large part of their fresh water. There are even floating desalination ships and mobile solar units designed for drought emergencies. So, the technology exists, but why isn't everyone doing it? Because it's ridiculously expensive and energy-hungry. Most desalination plants use a method called reverse osmosis, which forces seawater through filters so tiny they can block individual salt molecules. To push water through those filters, you need enormous pressure and enormous amounts of electricity. Think of it like trying to squeeze honey through a coffee filter. You can do it, but it takes a lot of force, a lot of time, and a lot of energy. Here's the wild part. If the entire world tried to use desalination as our main water source, global energy use could almost double. Wow, really? Yep, just producing enough drinking water this way could consume more power than all the world's air conditioners combined. That means while desalination is a technological miracle, it's also an environmental headache. You might think desalination is a distant problem, something happening in desert countries far away. But chances are you've already benefited from it without realizing it. That bottle of mineral water you picked up at the airport. Some of those brands come from desalinated seawater sources. The lettuce in your salad, if it was imported from water-scarce countries like Israel or the UAE, might have been grown with desalinated water too. So, in a small way, you've already drunk the ocean. But desalination also has a dark side, one most people never see. Every time we remove the salt, we're left with brine. Super concentrated salt water that's much denser than normal seawater. When dumped back into the ocean, it sinks to the seafloor, smothering coral reefs and marine life. It's like an underwater blanket of salt that suffocates anything beneath it. Some scientists even call it the ocean's silent killer. And that's the trade-off. We get fresh water, but we might be slowly poisoning the seas that gave it to us. Wow, really? Turning seawater into drinking water could literally kill parts of the ocean in return. That's why researchers are scrambling for cleaner, cheaper, and more sustainable solutions. Likes are the #1 way. YouTube knows this video is valuable. So, if you're enjoying this journey, please give it a like to help us out. Scientists are now developing solar-powered desalination. Instead of using massive electric pumps, they use sunlight to power a simple physical reaction. With materials called photothermal nanomaterials, they can heat the surface of seawater just enough for pure vapor to rise, leaving the salt behind. And here's the jaw-dropper. Just 1 teaspoon of these materials can purify a liter of seawater in under an hour, using nothing but sunlight. If scaled up, these systems could turn entire coastlines into self-sustaining freshwater hubs. Clean, cheap, and carbon-free. It's not just a dream. In 2023, researchers at MIT created a small portable desalination device that runs on solar power and can produce a day's worth of clean water for one person without filters or electricity. You could literally drink seawater on the beach. No machines, no pollution. Imagine a future where emergency zones, drought-stricken countries, or remote islands can all draw fresh water straight from the ocean, powered only by the sun. For the first time in history, drinking seawater might not just be possible, it might be sustainable. Here's the thing. This isn't just about science. It's about survival. By 2050, nearly half of the world's population is expected to live in areas with severe water shortages. Even now, cities like Cape Town and Chennai have already come dangerously close to running completely dry. And as climate change accelerates droughts and population growth, desalination might become our only backup plan. The ocean could become humanity's last, greatest reservoir. But if we're not careful, if we keep dumping waste and ignoring sustainability, that same ocean could become too polluted, too damaged, or too expensive to save us. So, could we ever drink ocean water safely? Technically, yes. We already can. But the real question isn't, can we? It's how we'll do it. Will we keep relying on energy-hungry machines that harm the planet? Or will we invest in innovations that make clean water truly sustainable for everyone? The ocean covers 71% of our planet, and it holds 97% of all the water we'll ever have. It's not that we're running out of water, we're just running out of drinkable water. Maybe one day soon, that will change. Maybe you'll turn on your tap, fill your glass, and take a sip, and realize that the water came from the sea. So, what do you think? If the ocean could quench our thirst, would we finally treat it with the respect it deserves? Or are we just finding new ways to take more than we give back? Let's talk about it in the comments. Because this time, what we decide to do with water might decide our future.